All right, we're starting. Okay, so my question is, who has not finished collection on data on all their projects? Okay, so you need to get that done, okay? So, quick reminder, we're going to cover chapter 22 today, which is on two proportion tests. On Tuesday, we're going to have a review. On Thursday, we will have the test. The rest of the time, we will work on your projects, okay? And then, if you get them done early, I guess we could be done a little bit early if you want to. Right now, we're scheduled to do those projects on the last day of the class. And the final exam will be the Monday and Tuesday of finals week in the testing center, the computer portion, and then on Wednesday of finals week, we will meet in our regular class for the written test. Does that make sense?
So we could technically be done with like class time if we finished our projects?
If you want to get your projects done early, we could be finished with class time earlier than that.
But just come back after that.
Right now, we're tentatively planning on having it on the last day of class, but if you want to move it up because you're all done, let me know, and we can do that, okay? So get it done. That's the main thing. Yes?
So today is the last day of instructional.
Of new material. We are going to spend some time because for the final exam, I know how difficult it is to pick the correct test. We're going to have some quizzes still, even though we're not done. The quizzes will be to prepare you for the final exam. They will go towards your grade. Okay? So that doesn't mean don't come to class anymore. Okay? But the main thing after next week is we're going to be reviewing and we're going to be working on your final project. Your final project you should think of as a final exam because it's that hard. And most of you are going to mess it up. Okay? But hopefully you won't. Okay? This is why we're going to hopefully get it right this time. Okay? All right. So, yes.
So you said that our test is going to be on Thursday, next Thursday?
A week from today, yes.
A week from today, that's our test. And the computer portion will be on Thursday, Friday?
No, I can't remember what I scheduled. Probably Thursday, Friday. Somebody wants to send me an email so I can check and remind me because I can't check in here. They've got the thing secure and it's annoying. Okay? All right, so chapter 22, excuse me, is inference on two proportions. Okay, now.
Does this say inference?
Inference on two proportions. I believe that's what the chapter title is. Let me make sure. That's what we called in my other class. Okay?
That's inference on two proportions?
Yeah. All right. So, wait a second. Is this really chapter 22? Yeah, it is. Okay, so now let me make sure I'm clear on this, okay? Because this is really confusing to students. On your poll, what's your poll question again? Should Donald Trump have a primary challenger, right? Okay, we're going to do, so is that going to be a 1 proportion or a 2 proportion test? It's going to be a 1. Okay, because the idea here is with a 1 proportion test, your null hypothesis is going to be P equals, and I'm just going to put some number, okay? In your case, you're going to find out, what was it? Was it 538.com? I can't remember where we got the number. You're comparing it to a national poll, right?
Right.
What was the national poll? I can't remember. I don't remember either. You should remember because aren't you working on this? No? Okay, so let's say it's 30%. I don't know what it is. It's going to be P equal to some number. Okay?
So our null is based off of what they said.
It's based off of what they said. Okay? So it's basically you're comparing it to a specific number. The idea with the project is you're comparing your results with their results to see if they match. Okay? With a 2 proportion test, the null hypothesis is going to be P1 equals P2. You're not going to compare it against a specific number.
So what would, like,
We are assuming these are independent, by the way. So for example, here's what we'll do. We'll do a little test today.
so would our candy be that 2 proportion test?
Your candy will not be a proportion test because this candy is weight a proportion.
I thought potatoes was weight, candy was distribution of.
That's what you told me. I only answered your question.
No, you said, do we do it?
Do we do a 2 proportion test for the candy? Because it's independent.
What are you testing?
Count the proportion of color,
Yeah.
How many colors are there?
like 5.
5 or 6. This is only 2. Okay? So what should the candy test be?
6 proportion. Marginal distribution.
A 6 proportion test, which we also call a chi-square
Square
test. Okay?
Yeah.
So don't mix them up. Okay? So if you have greater than 2 proportions, it becomes a chi-square independence test. Okay? All right, so I'm only bringing this up. I didn't realize that was a good question, though. This is what we're going to talk about today. We're going to talk about the 2 proportion test. Okay? So the rules here, and I got to make sure. Here, let me turn on my camera so you guys can make sure that I'm actually recording this, but it does say I'm recording. Okay? Rules. Okay, number 1, N1, P1, Q1 must be greater than or equal to 10, and N2, P2, Q2 must be greater than or equal to 10. Okay? Your number 2, N1 must be less than or equal to 5% of the population of N1, and N2 must be less than or equal to 5% of the population of N2.
Is that A and B?
Yes.
Oh,
And.
okay.
It's a hard word, A and D. Okay, actually, let me see if I can turn up this light. That didn't help. Is that better? I'm just trying to make that good for your film, but the problem is we got these lights. I don't know.
What is the
Good
big
reflection.
end? Big end is what?
The big end is your population.
Population.
This is your sample. Your sample must be less than or equal to 5% of your population. Okay? Trying to remember if there's any other rules there. I think that's the main ones. Okay? All right, so here's what we're going to do. We're going to do a quick sample here. And, number 3, the samples must be independent. By the way, I didn't ask you any questions on the quiz on that. Do you guys feel like you understand the difference between independent and dependent? Okay. Should have put that one on the quiz, huh? All right, so let's do a quick survey in here. And here's what I would like the question to be. In fact, I'm going to start sharing my screen here. All right. So now, by the way, remember on your poll questions, it needs to be a yes/no question. So that rule still applies. And so here's what we're going to do. We want to compare and see if there's a difference between the women and the men. So in the Democratic primary, do you prefer Joe Biden or Bernie Sanders. Now, I know that there are a lot more people running than just those two. But I can't do, with this test, you only get two choices, okay? So this is why I'm narrowing it down to two. You may hate them both, but in my poll, you have to pick one or the other, okay? So here's what I'd like to do. I want to compare the men and the women. Would this be an independent or a dependent sample? What's that? Say it again. This would be an independent sample, okay? All right, so I'm going to do Bernie and Biden, okay? So I only want the men to vote right now. Men, how many of you would, if those are the only two choices you could pick, how many of you would support Bernie Sanders? Oh man, it would be bad if we only have, okay, we got one at least. We're going to say if you get zero, this is not going to work very well. How many of you support Joe Biden? 1, 2, 3, 4, 5. Okay, hopefully we don't get zero on the women either. Okay, women, your turn. How many women support Bernie Sanders? 1, 2, 3. How many support Joe Biden? 1, 2, 3, 4, 5. Did everybody vote? Okay. All right, so now the question is, do we want to check Bernie support or Biden support? What would you guys like to do? Biden, okay? Okay, so the percent that support Biden, I wish we had a bigger class, but in this case, it's going to be 5 divided by 6, right? And this is going to be 5 divided by 8, okay? All right, so the question is there a significant difference among men and women who support Joe Biden? Okay. Now, 62 versus 83 sounds like a big difference, right? But look at my sample size. Number one, is my sample size big enough? When you can't even get 10 votes for either one, ain't no way. Okay? So here's what we're gonna do. We're gonna pretend that this is now 10 and 50, and this is 30 and 50. But for now, I messed that up. Is my sample size big enough now?
Yes.
Are you sure? Am I
No,
not?
no, it has to be greater than 30. So you need Bernie to have more.
This might be a question. How did you get the 0.833333?
I did 50 divided by 60.
Oh, because that's total, got it.
Yeah. Okay. So we need to check and see. Hopefully this is big enough. It might not be big enough. 30 is the wrong rule. It's N1P1Q1, right? So N1P1Q1 is what? N1 in this case is, for the men, 60 times P1, which is 83%, times 1 minus that.
60 times the percent.
N1P1Q1. Is it big enough? Not. Okay, we're going to multiply this by 100 now. 100, 500. Now it's big enough. We're going to do this one too. 300, 500. Okay, now it's big enough. We're going to pretend we surveyed 600 people. Okay? Just for fun. Okay? You guys are all representing 600 people. Men. Women are representing 800 women. Okay? All right, so now let's pretend these are my numbers. Okay? And we've got a big enough sample size now. Let's go through our hypothesis test. We've only got 15 minutes. We're going to have to go fast. Okay? First question is find the numbers, right? Okay, we found them. Okay? This is going to be P for the males. This is going to be, oh, I didn't fix that one. P for the females. Okay? All right, so now step number 2 is categorical or quantitative. Who says it's categorical? Vote. 1, 2, 3, 4, 5, 6, 7. Who says it's quantitative?
No, I go back to category.
You go back to categorical? Okay, good. Why is it categorical?
Because it's between two people.
Bernie or Biden, those are your two choices, okay? All right, step number 3 is find the null. No, it's not. No, it is. Find the null and the alternative hypothesis. What do you think, Brenda?
So, O, E.
It's on the board. Or are we sharing? Yeah, we are sharing. P1 equals P2, or another way to say that in our case, so we don't know what 1 and 2 are. P of males or men, that's a better idea, equals P of women, right? And the alternative hypothesis would be P of men does not equal P of women, right? Because before we voted, did you have any idea what the support would be? Okay. All right. So, question number 4 is pick the test. It's a Z or a T or a chi-square? Let's vote. Who says it's a Z? Nobody?
Oh, wait, is this for population or is it sample?
Is what for population or sample? This is the population, this is the sample. Right?
A sample t-test, a 2 sample proportion z-test, or an independence.
So let's just, I haven't taught you this yet, but let's just see if you guys can think your way through this. Who thinks it's a Z? Got 1 Z? Who thinks it's a T? We got 1, 2, 3, 4, 5, 6 T's. Who thinks it's a chi-square?
No, it's not chi-square.
Oh, he wants to fail the class.
You're kidding, this guy.
Okay, so was it Landon or Colin that picked Z? Colin picked Z. Why did you pick Z?
Because when I looked back to my notes, you gave us 3 tests for quantitative and 3 for categorical. And the one for categorical was 2 sample proportion z-test.
Okay, and why did you guys pick T? So he said because he looked at the notes and it said the categorical is a Z, right? For those of you who couldn't hear at home. Kensley, why did you pick T?
Well, to be honest, I was kind of 50-50 on all of them, so.
Well, 33, 33, 33.
But, no, I knew it wasn't the last one.
You knew it wasn't the last one.
So I was 50.
Okay, and you thought it was a T because?
That's what
That's what we just went over.
That's
So
what
that's
we just
like
went
what's
over,
in
it was
my
a T,
mind.
okay?
So Z.
Does anybody that picked T have a reason why they picked T?
I thought because the Z-score for the Z-test, you had to have the population standard deviation.
Population standard deviation, okay? Colin is correct in his reasoning. Because it's categorical, you can always figure out the population standard deviation yourself, okay? So it's a Z-test.
Because it's categorical.
Because it's categorical, that's why we asked that question. Is it categorical? If it's categorical, it's going to be a Z, or it could be a chi-square. This is not a chi-square, though.
But we can find the population standard deviation if it's categorical? That's what you said?
You can find the population standard deviation if it's categorical, and I'll show you how to do it right
Why would
now.
make it chi-square? If it was.
Chi-square is more than 2 proportions,
Okay.
like the M&Ms. Okay? Yes?
Z-test always categorical.
No, they could be quantitative. But all categorical tests, so all categorical tests in our class are either going to be a z or a chi-square. All quantitative are either going to be a z or a t. Okay? All right, so the equation of the day, the new equation of the day, is going to be p1 hat minus p2 hat divided by p times 1 minus p square rooted times the square root of 1 over n1 plus 1 over n2. Okay, I'm going to make sure that's the right equation, but I think it is.
The p hat.
Now, by the way, let me just mention this.
What does p hat mean?
Please do not read section 23.6 because we are not doing that method. That is the wrong method. So don't read 23.6. Okay, that's a bad method, and I don't want to teach it. Okay, but the equation there. Oh, I've written it differently. The equation is on page 536, although theirs is different than mine. This is the equation I want you to use. Okay, I want to separate these two square roots. Okay, they didn't separate them, but they should. Okay, this is the equation I'm going to give to you on your formula sheet. It's very similar to theirs, but there's a slight difference. Okay. Now the question is, what is p hat? What is p? We know what p hat is. P1 hat in this case is 500 divided by 600, right? P2 hat is 500 divided by 800. P hat will be x1 plus x2 over n1 plus n2. Okay? Now, in this case, we're counting the supporters of Joe Biden. Okay? So in our case, I am sharing this. It's going to be 500 plus 500 over 600 plus 800.
Because you just take the male, female, atom.
Yeah, we're adding up the numerators here.
Okay.
We're adding up the denominators here.
Roger.
Okay? That's all we're doing. Okay? Oh, there's got a glare on there. I'm sorry. All right. So in this case, let's go back to our thing here. We've got to hurry here. Okay? All right. So Z equals, in this case, P1 hat, which is going to be, I got to fix that number, but that number minus that number. This should be 83%. Let me fix it. Okay. And so that's your numerator. Your denominator is going to be p hat. We need to figure out our p hat. P hat is going to be the 500 plus the 500 divided by the 600 plus the 800. What happened here? That's not multiply. This number divided by that number. Okay, so about 71%. Okay, so this is going to be the square root of this number times 1 minus this number. Okay, that's the first part. And the second one is going to be 1, the square root of 1 divided by, we had 600 men, plus 1 divided by 800 women. Okay? So in this case, I'm going to get my numerator, which is about 20%, divided by the denominator, which is going to be this number times that number. Okay? Which works out to be about 8.53. Okay? This is my z-score. I was afraid that this would come out really bad, and it is, but that's okay. Okay? So essentially, what's going on? What's the next step after step number 4? We need to find the p-value. Okay, that's step number 5, right? Now, I'm 8.5 standard deviations away.
Yeah.
Do you think there's a significant difference?
Probably.
Yeah. Okay. So, do you remember how to do it on the computer? Norma's dist, right? Now, by the way, it's a positive number I got, right?
Right.
Before we do Norma's dist, we might want to draw our picture to make sure we know what's going on. Let's stop sharing for a second. Let's draw our picture. Okay? Yeah, that's probably okay. Got a picture of a bell curve, right? What's the mean of my bell curve? 0. What did I get? 8.53 standard deviations away. Here, I'll draw it here just to say this is the area that I want to the right. What's Excel going to tell me? It's going to tell me the white area or the black area? It's going to tell me the white area. How do I get the black area? 1 minus. Okay? So, if I do, come on. So I want 1 minus Norma's dist. Equals 1 minus Norma's dist of this. And that gives me a value of 0. Never report 0. Okay? If you were looking at your chart, 8 is off the chart, right?
Right.
So you can say your p-value is less than, say, 0.001. Well, we'll just say 0.01. It's much less than that. Okay? Never report 0 as a p-value. It's always going to be less than 0.01 or something. Okay? So in a way, that was good. Now, step number 6 says what? Reject or not, and in this case, we reject.
Reject the hoe.
And number 7, what does that mean? There is significant evidence of a difference between men and women's support of Joe Biden. Okay? Men are much more enthusiastic in their support of Joe Biden than the women are. Is that because Joe Biden kisses women in the back of the head? Have you guys been following the news?
Yeah, a little bit here.
Okay.
What happened?
You would walk up to women and kiss them in their hair. It was weird. Anyway. He's a friendly guy. All right. So the last thing I want to do would be,
I'm sorry, I wasn't listening.
the last thing I would want to do,
Make a graph.
confidence interval, right? Let me give you the confidence interval formula. Okay. Here is, I'll write it over here. Here's my confidence interval formula for 2 proportions. Okay. Now, let me throw this out at you. It might be interesting for you in your projects if you wanted to compare, say, men versus women or Republicans versus Democrats or something like that to do a 2 proportion test. But the main thing is I want you to compare it versus the national. Compare it versus the national will be a 1 proportion. But if you wanted to pick 2 groups of people, old people versus young people, men versus women, Republicans and Democrats, something like that, you could use a 2 proportion test. So the confidence interval for a 2 proportion test is P1 hat minus P2 hat plus or minus Z sub alpha over 2 times the square root of P1 hat Q1 hat divided by N1 plus P2 hat Q2 hat divided by N2.
Alpha
We're gonna need to use that?
Yes, we're going to do one right now. Okay. So let's figure out what would we, so we think there's a significant difference. We're about to tell how big of a difference there is. Okay. All right, so if we were to find a 95% confidence interval of the difference, okay? So you can see here when we did this earlier calculation, it looks like there's about almost a 21-point difference in men and women. Correct?
Right.
Okay.
Right.
Now, we can do our lower, we can do our upper. The lower will be P1 hat, which is the men, minus the women, P2 hat. I'm going to put that in parentheses. Oh, actually, you guys remember, and I'm going to do minus, do you guys remember what the 95% value is? For a 95% confidence interval, what's the critical value? It's 1.96. You look that up on the chart. Remember, it's close to 2. The 68, 95, 99 rule is close to 2. 1.96 up on the chart, if you don't remember, times the square root of P1 hat times Q1 hat, which is going to be 1 minus this number, divided by, we had 600 men that we interviewed, plus P2 hat times 1 minus P1 divided by 800 women. Okay? So I'm going to copy that and paste it here, and the only difference I'm going to do is I'm going to change this minus to a plus. Okay? So we got a 21% difference there. Do you see that? Almost 21%. We are 95% confident that the true difference between men and women is between 0.163 and 0.253. So it's anywhere between 16% and 25% difference.
So you state your confidence statement differently than we have in the past.
Well, here's the other question that I wanted to say. There's a true difference, and it's between 16 and 25%. Now, let me just throw this out at you. What if, instead of this, I had gotten negative 0.10, let's just say? Would there be a significant difference between men and women? Okay, under the null hypothesis, we say that men and women are equal, right? So if you subtracted them and they were equal, you would get 0. Is 0 in my interval? It is now because I faked it, right? So if you have a plus and a minus sign on your confidence interval, that means 0's in your interval and there is not a significant difference. If they're both positive or they're both negative, then there is it's significantly different from 0. So there's a significant difference. So in our case, it's a significant difference between 16 and 25%. Okay? All right, so your quiz on Tuesday will be on chapter 22. Remember to check the updated announcement for the homework. It's also updated on the syllabus. And see you on Tuesday.
Okay.
Do you want me to save this? Okay.
Thank you.
Mm-hmm.
I had a question for the project.